Here's a problem I was asked by a student, how to derive a difference equation for this problem that was first shown in an early homework example. So remember the steps we go to derive a difference equation. It's the first, you give each signal a name, a unique name before every delay. And the second is you write the equation around each summer. So let's do that for this problem. Let's firstly find the delays. How many of them? There's just one. There's just one delay right here. So we need to give a signal a name before each delay, and it's got to be a unique name. So we'll call this, say, W of n. And that means that right after the delay, if a W of n goes into the delay, W of n minus 1 must come out. Okay, no more delays. We're done with step 1. Let's do step 2. Write the equation around each summer. So we've got 2 summers here. Let's do it around the first summer up here. So that equation around each summer says, what do we have going into that summer? X of n goes into it. What else goes into it? Let's see, this W of n minus 1 comes up here. And so that becomes a minus W of n minus 1 signal. Now, the cool part about if you do step 1 correctly is every single signal line will have an unambiguous name. So again, finishing up that first summation line, we have X of n going in. We have we have a minus W of n minus 1 going in. And what comes out is going to be W of n. Okay, we've got another summer though. Our second summer is over here. So let's do this one. For this one, we've got 2 things going into it. We've got a W of n minus 1 going into it from the top. And from the right, we've got a minus 2 W of n minus 1 going into it. And we've got one thing coming out of it, and that's Y of n. All right, so we've done steps 1 and 2, and now all that's left is to do a little bit of algebra to figure out how we can get the output. So we have an extra variable here, W of n, and we want to get rid of it. Looks to me like a good way to do that is with this red equation. We can combine W of n minus 1 and minus 2 of W n minus 1 just to get a minus W of n minus 1, and that's going to be equal to Y of n. And so now we know that anytime we see a W of n minus 1, just multiplying that equation by negative 1, we can put in minus Y of n. And that helps us out with this green equation in the first place. But the second one asks for what's W of n. Well, if W of n minus 1 is this, then we can push our index up 1. We can just add 1 to our W of n minus 1. So now we've got this. So now we've got our 2 values for W, and we can put them right in here. So this gives us now X of n equals our W of n plus our W of n minus 1, moving this guy off to the right. But W of n is equal to minus Y of n plus 1. And our W of n minus 1 from the top is minus Y of n. So there's our difference equation. X of n equals, and I would write it just like that, minus Y of n plus 1 minus Y of n. Our x's are on one side, our y's are on the other. Whoops. Gotta love these fancy word options. And that's our difference equation. You'll never go wrong if you follow these rules up here, which is to first give every signal a unique name before every delay. And then the second is to write the equation around every summer. You'll have 1 equation per summer. So if you got 2 summers, you'll have 2 equations, and you'll have 1 extra intermediate variable you have to get rid of.